Cross derivation, what is that? RQ is equal to what? RQ is equal to X and RS is equal to L. Okay. RQ is equal to S. One second. So RQ is equal to S, RS is equal to L. So therefore, what happens? The magnetic flux phi B is equal to what? B dot A. Okay. So what happens? Phi B is equal to what? B dot A. B into what is area? Length into width. Okay. Length into width. After that, what we will have? E is equal to minus d phi B by dt. So that will be what? E is equal to minus d by dt of BLX. Okay. But what is variable out of these four? L is not variable. L is constant. Magnetic field is also constant. Only X is variable. So what is that? E is equal to minus B into L into dx by dt. Okay. Dx by dt. Now what is that? I am giving here E is equal to what? B into L. I am writing minus dx by dt like this. This minus dx by dt is what? B. BLV. Why I have taken B is equal to minus dx by dt? Because the distance is decreasing. See here, when it is moving, the x is decreasing. X is decreasing. When it is decreasing, I write minus. When it is increasing, I write plus. Is that clear? Is that clear, all of you?
Yes, sir.
Once
Yes,
again, see
sir.
from the beginning, RQ, length and width. Here, if suppose L is the length, X is the width, RQ is equal to X, RS is equal to L. Phi is equal to what? B dot A. Phi is equal to B into LX. Okay. E is equal to what? The induced EMF is equal to rate of change of magnetic flux, d by dt of phi B. So d by dt of phi B is what? BLX. BL you take comes outside and it becomes dx by dt. So it is minus dx by dt. So E is equal to what? BLV. And V is equal to what? Minus dx by dt. Is that clear?
Yes, sir.
Yeah, minus dx by dt. So that is a formula. Okay. So this is said to be the motional EMF. BLV is said to be the motional EMF. Please copy this. We'll go ahead then. Next derivation. Yeah. Oh, okay. In inductance, what happens here? In inductance, electric current is induced in a coil by flux change produced by another coil in its vicinity, or flux change produced by same coil. See here, there are two concepts. Like suppose there are this is the first coil. Now this is the galvanometer. Okay, galvanometer, and there is a second coil like this. There is a second coil. Now this second coil is connected to a switch like this, and this is a tapping key, not a normal key. It is a tapping key. When you off and on, okay, it's a tapping key like this. So what happens? The current, when it goes down, touches, current will go in one direction. When it is coming out, the current will go in the magnetic field will go in the opposite direction because of the changing current. Is that clear? Changing current produces changing magnetic field. When there is a changing magnetic field, current is induced in the second coil. Understood? In the beginning, there are three experiments. Either you move the coil is kept stationary like this, and magnet is made to move. It's the one way. Or keep two coils and keep on changing the magnetic flux of the first one. Then current will be induced in the second one. Understood? So this is the second way. So this happens in induction. Okay, the mutual inductance. Okay, this is about the mutual inductance. What is that? Phi B is equal to what? Phi B is proportional to, if you write here, phi B, if it is happening inside, this is said to be mutual inductance. This is said to be the mutual inductance. Is that clear? This is said to be the mutual inductance. Now suppose this is the same coil. Now what happens is here, this is, I'm connecting a battery, and there is a galvanometer here. Okay. Now, or I'm connecting don't connect a galvanometer also. Now there is a switch, tapping key here. Again, there is not a switch, but it's a tapping key. What happens? Like a bell switch. So when you already current is flowing through this one. Current is flowing like this. Magnetic field is produced around the coil. Okay, magnetic field is produced. But if you are tapping the key, there is a changing current. If you are tapping the key, there is a changing current. Changing current produces changing magnetic field. Changing magnetic field induces a current in the same coil again, but in the opposite direction. If this is the current which is due to the battery, and this is the current, this is the induced current which is due to the changing magnetic field. Understood? Is that clear? If this is the current due to the battery, and this will be the current due to the changing magnetic field, this current is said to be the induced current. This current is said to be induced current. So this induced current, this is said to be what? Self-induction. This type of inductance is said to be self-inductance, or is also known as back EMF. Is that clear? This is also known as back EMF. Is that clear?
Yeah,
is that clear?
sir.
So what he says here now, phi B is proportional to I. Change, that is changing magnetic field, the more the flux, more will be the current. Okay, so changing magnetic field, that you know that directly proportional. So the changing magnetic flux is proportional to what? Is proportional to di by dt. Changing current produces changing flux. So now we also know that n into phi b, if there are n number of turns, n into phi b is proportional to I. So n into phi b is equal to what? L into I. What is L? L is said to be inductance. Okay, inductance is measured in Henry. Units of inductance is Henry, H or Henry. Okay, so we generally measure in micro Henry, milli Henry, or like nano Henry, something like this. Okay, so these are the units of these are the units of inductance. Okay, and what is the purpose of inductance? Inductor is used to store magnetic energy. Okay, inductor. The purpose or function of inductor is it is used to store magnetic energy. It is used to store magnetic energy in the form of magnetic field. In the form of magnetic field. There is one more purpose for this, one more function. What is the function? That is, it is used for filtering process. It is used for filtering in electronic devices. Filtering in electronic devices. Filtering in electronic devices. What is a filtering devices? Means it blocks DC. It blocks DC and allows AC. And allows AC to pass through it. Okay, this is the second one. Clear? It is used for filtering in electronic devices. It blocks DC and allows AC to pass through it. Okay. So this was about the inductance. Okay, ml square t power minus 2, ml square t to the power of minus 2 and a power minus 2. This is a dimensional formula of this, and it is a scalar quantity. It is a scalar quantity. So tomorrow I will continue the class tomorrow then. Okay, I'll stop here for today.